So in today's lecture, we are going to discuss the Pascal's law and the Archimedes principle, right? First, we will see what is the Pascal's law. Pascal's law. What is the Pascal's law? According to the Pascal's law, suppose this is the container, right? This is the container and the liquid is filled like this everywhere. This is the closed vessel and the liquid or the fluid is enclosed in this closed vessel. Suppose this is the piston over here. Is it clear or not? So if you consider the point 1, right, point 2 over here, point 3 over here, or any point, the 4 you can assume at this point. Is it clear or not? So initially pressure, suppose at this point is P1, at this point is P2, at this point is P3, at this point is P4. Is it clear or not? So if you apply some force, suppose the area of this piston is what? Say A. So when you apply the force, what will happen? The pressure just below this will increase, right? By what amount the pressure will increase? Pressure is equal to force upon area. So the change in pressure, this is the change in pressure at this point P. Are you getting or not? So at this point, when you apply the force, the pressure is increased by delta P. So according to the Pascal's law, when the fluid is enclosed, right? So if at any point the pressure is changed by some amount, the pressure change will be transmitted to every point. Initially it was the pressure P4. Now the change in the pressure is same. It become delta P. It become P2 plus delta P. Is it clear or not? So according to the Pascal's law, in an enclosed fluid, right, the enclosed fluid, if the pressure at any point is changed, that change is transmitted to every point without diminishing magnitude. Is it clear or not? So I am writing the Pascal's law. So according to this, the pressure change in the liquid, in the enclosed liquid is transmitted to every point, right, to every point without diminish its magnitude. Is it clear or not? And this statement is called the Pascal's law. Is it clear or not? Varsha, copy this. So this is the Pascal's law, and there are so many applications are there. First application I am explaining, it's the hydraulic lift, right? I think you understand the hydraulic lift or any crane, right? You will see the jack, right? Whenever the tire of the car is punctured, so to change the stepney or to change the tire, we use the jack. Have you seen that jack, Varsha? Right, by applying a small force by your foot, the big car is lifted. So that is based on the principle of the Pascal's law. That is also called the hydraulic lift. The jack of the car is also called the hydraulic lift. And how does it work? Right, I explained. So in the hydraulic lift, the simple block diagram is that the liquid is enclosed in the 2 column, right? Suppose this is the smaller cross section, this is the bigger cross section. Is it clear or not? Like this, right? So if this is the smaller cross section, if we apply the force F1, the small force if we apply F1, all right, and the cross section is area is A1. Is it clear? To lift the car, suppose this is the big piston, the big mass is, right, placed on the bigger cross section like this. Is it clear or not? Like this, right? So when you apply the force, the area of this cross section is supposed to A2, the force F2, right? Suppose this is the mg, capital Mg, and this is the force F2, right? Is it like that? So what is the change in pressure at this point? F1 upon pressure is equal to F1 upon air. At the every point, just below this piston also, every point the change in pressure is transmitted without diminish its magnitude to every point. So at this point the pressure change is also equal to the same. And if this is F2, right, F2 is equal to what? Say mg, you can say this is the load, and the F2, the pressure is F2 upon A2. Is it clear or not? To balance this load, the pressure will apply this force. So since according to the Pascal's law, right, delta P is equal to F1A1 is equal to F2A2. Is it clear or not? This is the case. So the F2 is equal to what? A2 upon A1 into F1. For example, listen one more thing. This you may write like this: F2 upon F1 is equal to A2 upon A1. So A1 is greater than A1, right? So F2 upon F1 is greater than 1, implies that F2 is more than the F1, right? For example, I am taking an illustration. Suppose this A1 is 1 centimeter square and you are applying the force 10 Newton. This area A2 you may assume to be 1 meter square. So what is the F2 then? So how to find the F2? The F2 formula is A2 upon A1 into F1. When you apply the very small force, the 10 Newton, but the A2 is what? Say 1 meter square. What is the A1? 1 centimeter mean 10 raised to the power minus 4, right? Minus 4 meter square, and this is the 10 Newton. All right. When you will simplify 10 to the power 4. So F2 is what? 10,005 Newton. Is it clear or not? So by applying the small force of the magnitude 10 Newton, you can balance the load of 10,000 Newton, right? This is 10 to the 5. 1, 2, 3, 4, 5. 10 to the 5 Newton. Is it clear or not? Copy this. So now I will discuss the Archimedes principle. To understand the Archimedes principle, right, we must understand the buoyant force. B-U-O-Y-A-N-T, buoyant force, and Archimedes principle, right? Archimedes principle. All right. Buoyant force and Archimedes principle. Yes. What do you say about the buoyant force and the Archimedes principle? Please tell. What do you know? Yes. Can you explain something about the buoyant force? Yes, tell.
So when an object is made to be partially submerged or completely submerged, the force will act on it by the fluid itself.
Right.
The applied force on it, which is equal to the volume of water, which is the water displaced, fluid displaced.
Very good, very good. So I'm giving you the complete definition and you will understand in a correct way. Suppose there is a body, right? There is a body. When it is dipped partially or fully, for example, if it is the iron block or suppose it is the wood block, right? When you will leave this, right? When you drop this, so it will sink and it will float. How does it happen? So first of all, the buoyant force definition. Buoyant force. What is the buoyant force? B-U-O-Y-A-N-T, buoyant force. Right? I am writing its definition. Whenever a body is dipped, in the fluid, completely or partially, right? Completely and partially, an upthrust force in upward direction acts by the liquid at center of acts by the liquid whose magnitude is magnitude is equal to the weight of liquid displaced and acts at the point of center of gravity of liquid displaced. This is also the very important point for JEE Mains and JEE Advanced. The acting where the buoyant force act, the point of application is the center of gravity of the liquid displaced. This is the complete definition of the buoyant force. First copy this, right? For example, suppose this is the body. When this body is completely dipped, although the mg will act upon this. Is it clear or not? So this displaces the liquid, so therefore the buoyant force will act in the upward direction. What is the buoyant force? Equal to the weight of the liquid. Suppose the density of the liquid is rho L. In the same way, if suppose the body is dipped partially, is it clear or not? So the mg will act, and this is the volume of the liquid displaced. So the weight of this liquid displaced equal to the buoyant force. Where the buoyant force will act, it is also an important thing for rotational equilibrium, right? The buoyant force will act at the center of gravity of the liquid displaced. For example, the point of application of the, although listen one thing, if this is the solid body, right, like this, this is the, suppose this is the solid body like this, and it is floating by, because it is lighter than the liquid. So where the mg will act, you tell, where the mg will act? The mg will act at the center of gravity. Is it clear or not? Now where the buoyants will act? The buoyants will act at the center of gravity of the liquid displaced. By this body, this is the liquid displaced. Is it clear or not? This is the center of gravity of the body, and it is the mg acts upon this, but the buoyant force will act upon at the center of gravity of the liquid displaced, right? So this is the point of application of buoyancy, and this is equal to what? Say weight of liquid displaced. You understand or not? You tell. Varsha, can you tell me what is the weight of liquid displaced in this case? Suppose the inside volume is V1 and the outside volume in the air is V2. Is it, and density of the liquid is rho. Can you tell me what is the weight of the liquid displaced according to this? Yes. What is the weight? Say m dash g. Is it clear? What is the m dash? You tell. M dash is mass of liquid displaced. Is it clear or not? What is the mass of the liquid displaced in this figure? Tell me. Say mass is equal to volume into density. Volume into mass of liquid. Whose density will come? The density of the solid is suppose rho s. Which density will come? Very good. And which volume will come? V1, V2 or V1 plus V2? V1 only. So the buoyant force here will be equal to V1 into rho L into G when it is partially dipped. Is it clear or not? Now we come to this picture. What is the buoyancy in this case? Tell me. Say weight of the liquid displaced. Say m dash g. Is it clear? Can you tell me if the total volume of this block is V? Is it clear or not? So what is the m dash? Say m dash is mass of liquid displaced. Mass of liquid displaced. What is the mass? Say volume into density into G. Whose density will come? Very good. Look it. And what the volume will come? V. Because it displaces the volume equal to the volume of the body. So in this case, this is the buoyant force. In this case, this is the buoyant force. Is it clear or not? Copy this. Force. All right. So now I will write the Archimedes principle, right? This is the buoyant force, and then I will write the Archimedes principle. Listen one thing. What is the Archimedes principle? Is equal to the state equal to the weight of the this is also the buoyant force and the Archimedes principle, that is the same. Now I will write the principle of flotation or laws of flotation, right? Flotation, laws of flotation, right? This is the buoyant force, and the rest definition is equal of the Archimedes principle, right? Laws of flotation. All right, listen one thing. Suppose there is in this case, the case 1 I will discuss. First, suppose this is the body, right? The density of the liquid, rho L. The body is placed inside the liquid, suppose. Is it clear or not? So the density of the body is rho S, right? The density of the body is what? Say rho S. The density of the liquid is rho L. How many force will act upon? So this is the mg, and the buoyant force will act. Is it clear or not? So now in the case 1, if mg is greater than buoyant force, what will happen? You tell. Mg is nothing but equal to the weight of the liquid. What is the buoyant force? You will say the weight of the liquid displaced. The Gg will cancel out. What is the m? Say volume into density of solid. This is the mass of solid. What is m dash? Because it is completely dipped. So volume of liquid displaced equal to the volume of the body and the density of liquid. Is it clear or not? So the volume will cancel out. Density of the solid is greater than the density of the liquid. Or you can say the case 1, if density of solid is greater than density of liquid, implies that the mg weight will be greater than the buoyant force. Is it clear or not? For example, if you take an iron piece, right, and dipped in the liquid and release, so what will happen? Since mg is greater than buoyant force, so it will move down. Therefore, the body will move down. Body will move down, right, and sink. Is it clear or not, Varsha? In this case, can you find the acceleration? Yes, I can find. How? The net force is equal to what? Say ma. Can you tell me what is the net force acting upon the body? Tell me. How many forces are acting? Mg and buoyant force. So what is the net force on the body? Mg minus buoyancy is equal to ma. So here I am writing first. The acceleration is equal to what? Say mg minus m dash g. The buoyant force value is m dash g upon m. Is it clear? So listen one thing. The g is common. The m upon m minus m dash upon m. So acceleration is 1 minus m dash upon m into g. So this is the acceleration. You tell me, what is the value of m dash? M dash is, what is m dash? V, mass of the liquid displaced. What is the capital M? What is the m? Density. So therefore, the acceleration is equal to 1 minus volume of right g. Acceleration will be 1 minus rho L upon rho solid into g. So this is the acceleration. If you drop a heavier body in the liquid, so it will start sinking with this acceleration. Is it clear or not? Copy this. So this is the case 1, and the acceleration of the body will be downward, vertically downward. But if the lighter body is dipped in the liquid and released, then what will happen? I am writing here the case 2. Right. What is the case 2? If density of solid is less than the density of the liquid, it means the weight of the liquid is less than the buoyant force. Then what will happen, you tell? Right. You can make like this. Suppose this is the body, right? And you take, suppose a thermocol piece you have taken and you dipped into the liquid and then release. So how many force will act upon this? Tell me. Mg and Buoyant's force. Density of the liquid, density of solid. So because if Buoyant force is greater than mg, Buoyant's force mean mg is greater than mg, right? M dash mean volume into density of liquid, volume into density of solid. Liquid density is greater than the solid, body will move up. Are you getting? If it is moving up, so acceleration of the body will be upward direction. So what will apply? F net is equal to ma. What the net force is equal to ma, I will write. Tell me. Yes, B minus mg is equal to ma. So here the ma is equal to m dash g minus mg. Is it clear or not? So the best way to write this, you take the mg common. So m dash upon m minus 1 you will get. Are you getting this thing or not? You tell. Mm will cancel out. Acceleration will be equal to m dash. What is the m dash? Volume into density of liquid, solid minus 1. So the upward direction, upward acceleration will be equal to this much. Is it clear or not? The body will move up. It will start moving up, and after some time, right, it will start floating on the surface of the liquid, having some volume inside the liquid and having some volume in air. Body will move up and reach on surface of liquid, having, and start floating, having some volume inside liquid and outside and in the air, and some volume in the air, in equilibrium. This body is now in equilibrium. Do you understand or not? Here the buoyancy is greater than mg, but when it start floating, the mg will acting the downward direction. Now the buoyant force will be acting in the upward direction, although the line of the buoyant force will be like this. This is the correct way to represent. This is the mg and this is the buoyant force. Here in the equilibrium, buoyant force will be equal to what? Say mg. Although this buoyant force and this buoyant force will not be the same, so I am writing it is the b dash, right? B dash is equal to mg. Is it clear or not? First copy this, then I will try to find the volume V1 and V2. So in this case, how to find the inside volume, the liquid, and the volume outside in the air? Tell me. This body is now in equilibrium. Is this body in equilibrium? No, because the net force is not 0. When it is floating, it is in equilibrium. The B dash is equal to what? Same. What is the buoyant force? No, you will say the weight of the liquid displaced, right? The weight of the liquid displaced. What is the m dash over here? The mass of the liquid displaced. Mass is equal to volume into density. Whose density? Say liquid density. What is the volume of the liquid displaced? You will tell. V1. And what is the mass? The total mass is equal to volume V1 plus V2 into density of solid. So in this way, if the total volume you write, this is the V1 into liquid, so the V1 inside liquid is equal to rho solid upon rho liquid into total volume. Fine. And if you want to find the V2, so V1 plus V2 is equal to what? Say V is equal to V minus V1. This is in air. outside you can say. Fine. So V minus rho s upon rho liquid into V. So 1 minus rho solid upon rho liquid into V. This is the volume outside in the air. This is inside, this is the outside. In terms of the density, although we have derived this, but you don't remember, you need not to remember this as a formula. When we will solve the question, every time we will do this, and this is the concept, not as a formula. All right, copy this. Now, the case third is very simple. When the liquid density and the solid density are equal, so the body will remain as it is, where it is left, right? The case third, I am explaining, this is the case third. If density of liquid and density of solid are equal, so what will happen then? If it is released from rest inside the liquid, so the mg, and this is the Buoyant's force. The Buoyant's force and mg in this case, what is the Buoyant's force? Say m dash g. What is m dash? Volume into density. Whose density? Liquid density into g. And what is the weight of the solid? Volume into density. Whose density? Solid into g. But the liquid and density is solid, so they are equal. Therefore, Buoyant's and mg are equal. So net force is 0. The acceleration is 0. So if liquid density and solid density are equal, then body will be in equilibrium. When it is released inside liquid, it will remain on its position, right, as it is. Is it clear or not? Copy this. Now I am giving you one example, and you have to understand, also memorize. Can you tell me what is the density of water? Say 10 to the power 3 kg per meter. Yes. What is the density of the ice? Density of ice is 900 kg per meter cube. Is it clear or not? You have to remember some data, although it would be given in the question, but at least we should know the density of the ice. Fine. So if this is the cube of side, ice cube of side 10 centimeter is floating, because the density of ice is less than the density of the water. So ice will float or not, sink? It will float. 10 centimeter side is floating on surface of water, right? You have to find, right, the length of cube inside water, right? For example, I'm making the figure. Although this is the question, right, the solution I'm writing and giving you the idea. This is the water, right, and this is the cube. What they are asking, if the cube is floating, so what is the distance inside the water? They are asking when it is floating. You understand the question? Copy this. How to solve this question? It is in equilibrium or not, you tell? Yes, it is in equilibrium. How many force will act upon this? Say mg. And suppose this is the V1 and V2. The Buoyant's force will act at the center of gravity of the liquid displaced, and this is the Buoyant's force. And the B must be equal to, say, the mg. What is the Buoyant's force? Say weight of the liquid displaced. The gg will cancel out. So what is m dash? So therefore the mass of the solid is equal to the mass of the liquid displaced. What is the mass of the solid? Can you tell me? Say volume into density of solid. Density of solid mean density of ice. What is the mass of the liquid displaced? Say volume into density of water. What is the volume? Say V1 will come. Is it clear or not? So what is the total volume of the, this is 10, this is 10, this is 10 centimeter. Is it clear or not? So 10 into 10 into 10, I am taking the SI unit only, right? And this is the volume V1. This volume V1 is what? 10 into 10 into X. 10 into 10 into X into raw water. Tell me, this calculation you are getting or not?
Yes.
So 100 will cancel out, X into raw water, 10 into raw ice, right? So what is the value of X? 10 into raw ice divided by raw water. Raw ice is what? 900, and the raw water is 10,000, so 9 centimeter. So it means what? The X is 9 centimeter. It means, right? So 9 centimeter, the cube is like this. This is the 9 centimeter inside, and the outside will be 1 centimeter. So 9/10 portion volume is inside. Is it clear or not? In the liquid. Varsha, you are getting this thing or not? You tell. Copy this. So in this question, what is given? This is a wood and it is floating. This is the cubical box of the wood, right? Similar to the previous problem. All right. And the weight is given. The site is 30 centimeter, 30 centimeter, 30 centimeter. So what they are asking, calculate the depth. This depth they are asking, such that, yes, the mg, the mass of this cubical block is given to be 21.6 kg, and therefore the Buoyant force will act. Although this is the weight mg will act the center of gravity, the Buoyant force will act at this point. So B must be equal to what? Say mg. Can you tell me what is the Buoyant force? Tell me, Varsha. Say equal to the weight of liquid displays. Weight mean the m dash g is equal to m into g. The m dash is equal to m. What is the m? Say mass of solid. It is given in the question. What is the m dash? Say mass of the liquid displays. Mass of the liquid displays. Although it is water, right? So the volume into density of the water. What is the volume? You will write 30 into 30 into x. So because everything is in SI unit, so volume I am writing what? 0.3 into 0.3 into x, right? Into raw water. So this is 0.09 x into 10 ki power 3 is equal to 21.6. So x is 21.6 upon 90. Is it clear or not? If you multiply, when you will simplify, what the answer you will get? You will get 0.244 meter, and therefore the x is equal to 24 centimeter. Is it clear or not? Copy this. So in this question, write the block, the density of this block, it is connected to the spring. Are you getting or not? When it is in air, you tell, what will be the reading? Reading will be equal to the tension. So here the mg and tension are equal. Are you getting or not? This is the block whose density is what? Density of solid is 8000 kg per meter cube. Are you getting or not? What is the density of water? Varsha? 1000. And density of brass is 8000. 8 times heavier the brass is. Now when the system is dipped into the liquid, here the reading will be, right, the 0.5 mg. Right now this system, if is dipped in the water, then what will happen? You tell. The reading is nothing but equal to the spring force over here. Suppose this is the T dash now, the mg, and the Buoyant force will acting upward direction. It is in equilibrium, right? What is the equilibrium? Net force is 0. What the equation I will write? T dash plus buoyancy is equal to mg. Is it clear or not, Varsha? The T dash will be the new reading over In this case, the T is equal to mg. So what is the T dash? Say mg minus buoyant force. Can you tell me what is the buoyant force? Yes, buoyant force is nothing but equal to the weight of the liquid displaced. You will write like this always. It is easier to understand. Now you take mg common, m dash upon m. Is it clear this step? If you take mg common, m dash g upon mg, gg will cancel out. So now the new reading T dash, they are asking, tell me what is the T dash? Say mg. 1 minus volume, because it is completely dipped. So volume of the liquid displaced is equal to volume of solid. What is the m dash? Mass of the liquid displaced is equal to volume into density. Whose density? Liquid. It means water. Whose density? Solid or the brass. Volume will cancel out. What is the m? Say 0.5. What is the g? Say 10. Rho water upon rho s. The density of the water, say 1000. Solid, 8000. 5 into 1 minus 1 by 8. Are you getting or not? So this is equal to what? 5 into 7. 5 into 7 upon 8. 5 but 8 Newton. The answer is given in the Newton. Is it clear or not? Right. So how much it is? The reading will be 4.24, right? 4.375 Newton. This is the Newton, but if due to some reason they want to find the kilogram, so the reading in kgf, right? 4.375 upon g, right? 0.4375 kg will be the reading, right? But they are asking the Newton only. Is it clear? Copy this. So in this question, what we have, cubical block is floating in liquid, the half of its volume is the liquid. So if this is the initial condition, it is at rest, right? The liquid density, right, will be more, and the density, this is the V and this is also V, this is the V by 2 and this is also the V by 2 initially, right? In this case, what will you apply? Say mg into Buoyant's force, and the Buoyant's force and mg both are equal or not? Yes. Buoyant's force is m dash g is equal to mg, gg will cancel out. So what is the m dash? Is equal to m. Are you getting? M dash is equal to volume into density of liquid. What is the m? So total volume is V. The total volume is V and the density of solid. We will cancel. Liquid density is equal to 2 times of the solid density. This is the relation between the density of liquid and density of solid. Now in the second case, it moved with the acceleration g by 3, by some acceleration, suppose g by 3. Now what will happen? Suppose, right, this is the volume, this is the V2, the mg. Okay, when you sit on this vessel and when you are sitting, its acceleration is a. So what will be the, you tell me, what will be the g effective? Say g plus a. It will be the weight acting or not, you tell. And suppose V1 is inside, what will be the Buoyant force? Say B. It is in equilibrium again. The m dash, you tell, Buoyant force is m dash. G or G plus A? G plus A. So I think it is very much clear. The m dash is equal to m again, right? The same thing. So it means there is no change in the volume submerged. V1 and V2 will be again V by 2, V by 2. It is equal to what? Say V1 into density of liquid. This is V1 plus V2 into density of solid. So density of liquid is 2 times of density of solid. Solid cancel out. So V1 and V2 both are equal, which is equal to V by 2. So what they are asking, fraction of volume immersed. So they are asking V1 upon V1 plus V2. This is the fraction. So it is V by 2 upon V, it is equal to 1 by 2 is the correct answer. So there will be no change when it move up or go down. The volume submerged will remain as it is. Is it clear? Copy this. So in this question, suppose there is a beaker, right? And I told you if some body is floating over here and it is at rest, so mg will act and the bind force will act and this bind force is nothing but the upthrust force. So what is the upthrust force? Say m dash g. Are you getting or not? But due to some reason, if the acceleration is a downward, so the weight of the liquid with respect to this beaker I am explaining, the g minus a. Is it clear or not? And therefore this also become z minus a. So if this acceleration is equal to z, then what is the bind force or upthrust force? Say g minus g is equal to 0. What is the weight? Say g minus g is equal to 0. So but they are asking what? The upthrust force. Upthrust force mean the bind force is equal to 0. So what is the answer? Say the A option is the correct option. Copy this. So in this question, we have done this type of concept. The rubber ball is there, right? And the mass, the acceleration of the ball, the volume. Listen, the mass of the rubber ball is what? Tell me. The mass is 10 gram. The volume is 15 centimeter cube. So m is equal to volume into density. So what is the density? The mass upon volume. The mass is 110, volume is 15. So the density is 2 by 3 gram per cc. Right. While this is the density of the solid. What is the density of the water? Say 1 gram per cc. If you understand this. Getting or not? So you tell me whose density is greater? Density of the water or density of solid? The solid density is less. So when it is released from rest inside the water, where it will move? Upward. So can you find the acceleration? The Buoyant force mg. What they are asking, acceleration of the ball in the first part. F net is equal to ma, can I apply? Yes. The Buoyant minus mg, can I apply? Yes. The Buoyant force is m dash g minus m is equal to what is the acceleration? Say if you take g common, m dash minus m upon m. So what is the acceleration? M dash upon m minus 1 into g. What is the m dash? Say mass of liquid displaced. Volume into density of liquid, volume into density of solid minus 1 into g. Both volume are equal because it is completely submerged. Is it clear? So what is the density of the water? Say 1. Density of solid 2 by 3 minus g. So this is 3 by 2 minus 1 into g. So what is the answer? Say g by 2. So acceleration is g by 2 or 5 meter per second square. You can write. This is the answer number 1. In the second part, the depth of this water depth is 10 meter. So it start from rest, u is equal to 0. What time it will reach at the surface? So how to find? Say s is equal to ut plus half at square. That's it. The initial velocity is 0. The distance which has to move, say 10 meter, 0 plus acceleration is what? Say 5 into t square. So the t square is equal to 10 into 2 upon 5. So t square is equal to 4. T is equal to 2 seconds. Is it clear? Although in the question the g value is 9.8 meter per second square. If you put this value, a little difference you will get. Is it clear? Copy this. So in this example, suppose this is the body. In the air, suppose this is the spring, right? The weight is measured by the spring balance. Suppose this is the 160 gram in air. So here is the tension. When it is dipped in the water, suppose this is the water, Are you getting? So in this case, the T1, although this is 160 G, so this T1, because the Buoyant force V1 is acting, so because of this Buoyant force, the T1 is reduced to 130 G. This is the water. And in the second case, the same body, the mass is 160 gram in air. Now it is dipped in oil, right? The density of the oil is rho oil, density of water is rho water. In this case, the tension is T2, right? And it's come to be 130 gram, and this is 160 G. This is the buoyancy B2. Are you getting or not? So that is the thing. So what is the Buoyant force over here? You tell. Buoyant force T1 plus Buoyant force is equal to what? The mg. So Buoyant force is equal to mg minus T1. Is it clear or not? So this is 160 G minus 130 G. This is the B1. Are you getting? In this case, T2 plus B2 is equal to mg again. So what is the T2? What is the B2 over here? The B2 is nothing but mg minus T2. So mg is 160 G minus 136 G. Is it clear? This is the B2. What is the Buoyant force? You tell. Buoyant force is nothing but the weight of the liquid displaced. The volume is V, the density of water. Is it clear or not? You tell. Varsha. And what is the B2? Is the Buoyant force in the oil is equal to weight of the liquid displaced, volume into density of liquid. Is it clear or not? You tell. Here the density of liquid. Is it clear or not? So they are asking the specific gravity. What is the specific gravity? Ratio of the density of oil. You can assume this is the oil with respect to water. I am writing, here is the density of oil. The density of oil. So rho L upon rho water we have to find. So this is the equation number 1, equation number 2. So if you divide 1 and 2, what will you get? Density of oil, density of water. 160 G minus 136 G upon 160 G minus 130 G. So this is density of oil and density of water. This is what? This is nothing but loss. In oil, loss of weight. In oil, this is the loss. Although it is 160 and this is showing 136. So what is the loss? The B2 is equal to the loss. And what is this? It is 160 in air and in water it is 130. So the losses also occur in water, also occur in liquid. So this is equal to what? Loss of weight in water. Right. So it is equal to how much? 24 G, and this is what? Say it is 30 G. Right. 6 चौक 24, 6 पंजे 30. This is 0.8. So the specific gravity is equal to density of oil upon density of water is 0.8, and the formula you can write the loss of weight in oil, ratio of loss of weight in oil and loss of weight in water. You may assume this, you may consider as a formula as it is given in your book. All right, copy this.